All right. So thank you very much for joining, guys. So I think it's 2 minutes past 9 where I'm at. So let's get started and let's talk about how what are the 5 tips for safely using AI generated code. Now we are AutoRABIT. We are in the business of making Salesforce deliver, making Salesforce work. We have a few products that sit across the entire Salesforce SDLC. So today we're going to be talking about how one of our core products, CodeScan, helps in making in using AI generated code safely, and we'll also jump into a demo in order to see how that works. Josh, how about we get the next slide, please? All right, a little bit about me. My name is Prashanth. I lead the solution engineering here at AutoRABIT. Before this, I was the head of product for AutoRABIT for the longest time I know. I've been around Salesforce for close to 2 decades now. Started working with Salesforce right after I started working as a Java developer, and from Java developer, I became a Salesforce dev. So that's a little bit about me. Josh, let's go to the next slide, please. All right, so let's talk about why a few important baseline topics before we actually get into talking about how we as CodeScan and you as Salesforce admin developer needs to be cautious about on using AI generated code. So first and foremost, cloud has taken off, and Salesforce is one of the is the uncrowned king in the world of integrated cloud stacks, which meaning that Salesforce has this unique perspective where they combine software as service, platform as service, and infrastructure as service in order to deliver an integrated cloud experience for their users. Now, and this also means that a lot of the ownership of maintenance of configuration, maintenance of access controls, maintenance of data falls on the customer. Josh, can you build this entire slide out, please? All right. So what we're trying to showcase here is most of as we step into the future of this integrated cloud stack, the responsibility of the customer's data will be more and more on the customer and less on the cloud provider, which is Salesforce themselves. So any kind of misconfigurations that are happening in your system, any kind of access control violations or elevation of privileges that are happening in the system are in the Salesforce org. When I say system, the Salesforce org would be the responsibility of the customer and not of Salesforce. Now, Salesforce is built on a trust layer. Just next slide, Josh. Salesforce is built on a trust layer. You guys know this. If you've been around Salesforce, you know how well Salesforce manages this. There's a website, trust.salesforce.com, where you can see what is the maintenance window of every server that Salesforce has, every service that Salesforce has, and how they, how they're running their uptime. Yeah, and if there are any kind of security incidents, they're almost on top of it, like super quick. For example, when the new polyfill vulnerability was discovered, polyfill is a CDN library that is used across the world by JavaScript developers in order to serve content cross browser. And when this vulnerability was discovered, Salesforce was on top of it, like in all major companies, and put out a notification and steps on how to remediate it. So Salesforce is on the top of of making sure they are securing the customer's data as much as possible in in the sections that they are responsible for. But there are other places where the customer themselves would be responsible for that particular data, like who is accessing your system. Are you taking care of your guest profiles? Are you using a user mode or system mode when you're writing DML queries and so on and so forth? So when the sprawl of making mistakes is super large, And when you drop in AI into it, it becomes even more challenging. So what we have, our value proposition is how you can use our tool, CodeScan, in order to make sure that even though if you're using AI generated code, you would be able to sort of prevent some of the major security hotspots or vulnerabilities from sneaking in. So that's the context of our discussion today. Josh, next slide, please. So, like I was saying, this is a very good representation of the shared responsibility model. So, Salesforce takes care of the 7 layers of security, the network security, and everything on top of that in terms of the data access, the codes, the flows, integration, end users, and community. They're all the responsibility of the users. So, when your admins or developers are using AI to generate this code, AI does not have the context of this data access. AI does not have the context of your Salesforce metadata unless until you use some sort of RAG system in order to train it, or some sort of a human feedback loop system in order to train a Salesforce org on the complete metadata or data schema. But since that has not happened yet, the context is the AI that we'd be using, and most likely, the mostly used AI that we are seeing is ChatGPT or Open AI's 4.0 or 4.0 mini. That is probably the most used system, and that system does not have the context of your Salesforce org. Whatever context it has is the context that you provide in your prompt. So however you're building your prompt, it could be using chain of thought or zero shot or one shot or two shot. It still does not have the entire context of your Salesforce org. So that said, let's get into a little deeper into this. So next slide, please. So some of the surveys that we have done across our user base, we found out that generative AI is here. And admins, developers, not just in Salesforce, outside of Salesforce, are also using natural language in order to communicate with the GPT in order to get more efficient at their work. So 55% of the workers have admitted that they are using unapproved AI tools when GPT was first announced. Most companies sort of put out a new policy in their orgs, asking users not to use GPT or not to use AI systems unless they are approved. Unfortunately, GPT is something that works on your phone, works on your browsers. Giving it a prompt and feeding it some context of your code is actually easy, so people are already using it. 40% of generative AI users have been are used banned tools at work. Now, one of the other things that most people don't realize is the GPT, where T is a transformer and G and P are the generative pre-trained transformers, are somebody's training on a foundation model. So uh, and it's just not OpenAI's models that are available out there. If you look at Hugging Face, which is like the repository of models and data sets in the world of AI, you would see there are about 28,000 or even more models out there, and we have also found users sort of not who do not want to pay OpenAI or hitting the paywall at other AI tools are using free models that are available on Hugging Face in order to generate code. So we are trying to surface this information as much as possible so that enterprises put in the guardrails that are necessary in order to secure AI. So that's it. Josh, can we go on to the next slide, please? All right, so the risks of generative AI are real. The models are not 100% reliable. Like I said, they do not have the metadata context. They often store the information that you're sending them in prompts, and some models also train their, fine tune using the prompt information that you're providing them. The security and compliance context that a model has is not, the model does not understand your security needs or your compliance needs because it does not have the context of the org. Some of the the top security risks that we are coming across are, well, the first and foremost is prompt injection. Then the hallucination of the model, the training data poisoning, where we are hearing that models are being poisoned, and those poisoned models can be used in an RAG system. RAG stands for Retrieval Augmented Reality, where you can give the model context, more context of today or context of your system, which provides better results, and which is probably one of the most used functions of AI. In other ways, we are seeing the model denial of service and model theft are not really in the Salesforce realm, but we just wanted to put that out there so that people realize that, apart from the application security, that generally InfoSec teams are uh, all over it, right? Like InfoSec teams want to have the right scanners for static code analysis or dynamic code analysis or whatever, but there's a new section of scanning that is coming out where you're also having to scan the models that are being used in an enterprise. So we just wanted to put that out there so that our customers understand the risks of AI are real. So that said, can we move to the next slide, please? Okay, so the top tools that are being used, if money is no object, what we realize, GPT-4 is on the top of the charts, followed by Claude 3 Sonnet, followed by Google's Gemini 1.5 Pro, followed by Code Llama, which is from Meta, and on and on. And if you look at all of the code models that are available in Hugging Face, you would see that there are about 28,171 models. So what that also, you can also translate that to say that users, Salesforce admins, developers have 28,000 ways of using code generation tools and not just Einstein GPT or other GPTs that are available. Are luckily Salesforce is not far too behind in producing the best, the meanest, the baddest, the biggest model. But Einstein GPT is also one of the top models, but it's not in the top 50, but it is fairly competent. And the reason why I'm pointing this out is because most of our Salesforce admins and developers would be using Einstein GPT, and by not using a more context heavy or a parameter heavy model, is the kind of output that it'll spit out would be limited, and the context tokens that it can digest would be limited. So that said, Josh, can we go on to the next slide, please? All right. So what are the 5 things that you as Salesforce org administrators can take care of? The first and foremost is setting up a comprehensive static code analysis. The GPTs or any of the code generation models that are available out there, even when when the admins, developers are using them, they have to get it back into the system. So it is great to have a comprehensive code analysis system that is trained, or that is trained to look out for common issues, which understands the Salesforce languages of flows, Salesforce languages of not language, but Salesforce metadata like profiles and objects. So it is, irrespective of where the code is being generated, either it could be an IDE, or it could be directly on the dev console, or it could be directly in the Salesforce org itself. Irrespective of where you're doing it, you can always have gates by using a comprehensive code analysis tool that looks for common issues and is able to prompt the system, the team, saying, providing this information that ABC has gone wrong, and here's why it is wrong, and here are some of the steps to sort of deal with it. So our first step is to make sure that you guys have a comprehensive static analysis tool that is trained on Salesforce, that is trained to do automatic detection. Josh, next slide, please. The next step that we have is to have strong quality and security gates. These gates are that we offer in CodeScan are customizable and you can enforce them. Now, having these gates are a good way to stop from garbage from coming in. So even if your model is generating garbage, you can create a system where the model, whatever garbage the model is generating, you're able to catch that. So, one of my mentors used to say, garbage in is garbage out. So you got to make sure that you're able to catch bad code, unclean code, code that does not have the right code styles, code documentation, error handling. You stop all of that code at its origin and ask developers to do a better job of create writing clean code. And we have a philosophy in CodeScan called clean as you code, which helps you sort of identify what are the areas in which broken down at a severity level from critical, major, minor, and so on, where you can decide what are the issues that you wanna address and that you want to fix. Next slide, please. The next tip that we have is to focus on governance and compliance. So if you are a regulated industry, or if you're a Salesforce administrator or Salesforce owner in a regulated system, then you have to make sure that your Salesforce is code is meeting the standards of GDPR or CCPA or SOC 2. So you need to have those compliance and governance controls around the code that is getting generated by the model. So, for example, if the model is writing a SOQL query, you got to make sure that you check the access controls around that query to make sure that it is in the realms of your compliance and regulatory standards. The next step that we have, Josh, next slide, please, is to have a CI/CD integration. And for CI/CD integration, you can effortlessly use any of the CI/CD tools that are out there. That includes Jenkins, GitLab, Salesforce DX, AutoRABIT, ARM, and so on and on and on. Where by having a CI/CD integration, what you're doing is you're enforcing a comprehensive static code analysis. You're enforcing a quality control, which is a security gate, and you're enforcing governance and compliance tools. So CI/CD helps you bring all of that, into one place. And irrespective of where you are in your code promotion, you would be able to sort of capture those issues and have a plan to remediate those issues. Next slide, please. Finally, have a visibility system where all of these information are visible for the entire team. CodeScan provides a detailed analysis, if you like a report card of how your code is doing. So on the screenshot on the right there, you can see the score for reliability, a score for security, a score for security review and maintainability. This helps you as a team to all look at the code from a common perspective, from a common context, to understand how your team is doing. And you can report on this. You can share these reports among your team and sort of elevate your team to write better quality code. So these are like the 5 tips that we would say are super important for the Salesforce community, and not just the Salesforce community, but the DevOps community in general. If you're using models, there's nobody that can stop the usage of these models. They're already being used, but you can have the right controls, the right gates, in order to make sure that even though these models are being used, you're able to capture the issues that are being put out by these models, or the bad code that these models are trained to write, are being caught in their nascent stage. So with that, Josh, can you give me the next slide, please? So our value proposition is the following. So AI generates the code in an IDE or anywhere in the developer org or in the Salesforce org. Scans the code in real time, and it recommends fix for those vulnerabilities. So I'm going to give you a small demo of how that exactly works. Josh, can you go to the next slide, please? All right, fantastic. So let's go and do a quick demo here. Let me just pull up my IDE so that we can see this in action. All right, thank you for being very patient with me. So I'm just loading up my IDE system here. Let me share my screen. All right. I hope you guys are able to see my screen. So here I have um, my dev cons or my IDE. Yeah, it's a VS Code IDE that is running the Dreamhouse LWC. Dreamhouse LWC is a popular free Trailhead app made available by Salesforce. This is generally that what we use in order to showcase our demos because it's very comprehensive in terms of using the different aspects of Salesforce features, right? LWC and whatnot. So let's say that I'm going to try to use the Einstein GPT here. So I have the Einstein GPT pre-installed here. So I can give this any prompt. So as you can see, I was working with some prompt some code earlier here. So let's say that I have this class, right? And I can see that under the problem section, CodeScan was able to find 11 issues. So this IDE is running Einstein GPT, CodeScan, it is running Git, it is running Atlassian, some Atlassian tools. So it's like an integrated solution architecture where you're able to leverage the best of all the tools. And the user gets to decide what is adding the most amount of value and how to take most amount of value from each tool. So let's say that I have this issue. Permission needs to be checked before accessing content version. And this is coming from CodeScan, which is a field level security issue, right? So what I can try to do with Einstein GPT is I can try to capture this entire code, and I can send this to Einstein GPT and say fix permission issues such as accessing resource content version, right? I can send this information to Einstein GPT, where Einstein GPT is going to think that information, think that relook at that code, look at my prompt, everything that I sent, and it's going to give me a code that probably has the context. So if I take this code, copy this code, and paste it, replace my code, I can, this is the new code has a user mode, which basically is going to check for that content version. So it is a better quality code that has been written. So if I when I save this file, CodeScan is going to recheck for that class. So I'm going to quickly go ahead and save this. So, and it looks like it has found some other errors in terms of the unexpected tokens and stuff like that. So this is to show you how you can generate bad code from Einstein GPT, and you would still get into different errors. Now, there's another example that I want to show you guys where you can generate a test class from Einstein GPT, which is one of the most used features of Einstein GPT. So if I say that generate a test class, I can say I can choose which which methods I want to use here. So once I've select that, a new test class would be generated for me or in the IDE. So this will just take me a few seconds for Einstein GPT to generate it. There you go. So this is a new class that has been generated by Einstein GPT. And as you can see, once the code is generated, CodeScan was able to find issues right off the bat. I don't know if you blinked, you might have missed this. So I just generated this test class, and it has found 48 issues on this class. So by going through each one of these issues, and you can see why something is an issue, and you can see what does it take to fix those issues? What is a good argument to write in order to not get those static code issues? And this is like an integrated system where you can use Einstein GPT, where you can use CodeScan in order to clean as you code. So it'll once you write your logic using any model, or if you're trying to clean up your code using any model, you'll be able to bring these systems together in order to write comprehensive code. So so that is what we wanted to show you in terms of how you can use CodeScan. And now I can tie this up to a quality gate. I can tie this up to a CI/CD system and really enforce those quality gates. But I hope the tips that we provided you on this webinar are going to be incredibly useful for you in terms of, just to recap what those tips are. So in order to reinforce what the tips are, you got to have a comprehensive static code analysis tool. You got to have quality gates. You have to check for governance and compliance. You have to check for you need to have a CI/CD system where you're able to catch these issues earlier.